Which of the following compounds can be synthesized by radical halogenation with almost no isomers of products? So when you do radical reactions, then it is very common to form more than one product. Okay, and so here is an example of how you figure out how many products you will get. So these are the products that we have. Okay, so what kind of a starting material do you need here? For this one, you will need a cyclopentane. So yeah, when you do the chlorination on this one using radical reactions, then you will get only one product. Okay, provided you're doing only one chlorination. So monochlorination will give you only one product. So this is a really good kind of a reaction to do. The second one that we have here, for this one, your starting material that you will need would be a butane. So when you have a butane and you're doing bromination, okay, bromination is kind of a little slow reaction. So for bromination, because it's slow, it likes to go to carbons that are more stable or carbon intermediates that are more stable. So the the one intermediate that's possible is going to be this radical, which means that this product that is shown up there is probably not going to be the more stable one. The more stable one that you're going to form is this one. Okay, so which means that in this case you will not have only one product. Okay, you will have more than one product because you can have another stable radical here. Okay, let's look at the next one now, where you have chlorination going on. And one of the things about chlorination is that it's a very fast reaction. You get multiple products already, but in this case, you know, this has to be your carbon chain that you start with. And so if this is your skeleton that you're starting with, well, if you're doing chlorination on this one, okay, you will just not get any just one product. Okay, you will get many products in this because you can get substitution here, 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 and here, and here, and here. So you probably will end up with 6 products, okay, in this one. So definitely not a very good one to work with, okay, using a free radical mechanism. All right, let's look at the last one. So in case of the last one, now we actually have this kind of a skeleton, a cyclohexane, dimethyl cyclohexane, and in this case the bromine is actually going to one of the tertiary carbons. Okay, so which means on this carbon right here, and if this is the carbon that it's going to, then it's fantastic because first of all we have 2 of those. The other thing is, as we just said, if you're doing bromination on any alkane, then bromine likes to go to a more stable radical, and this is going to be the more stable radical. Okay, so let me write it out as an intermediate, and so this is the radical that's going to be formed, and so this will be the more stable one. So yeah, this is really good one to make using free radical mechanism. Okay, so you have to look at the intermediates and then figure out how many products you will be able to get.